I just want to give you a couple of experiences, share an overview around FenestraPro, those kind of couple of drivers within the market that led us and enabled us to get to where we are. Talk very briefly about the functionality and what we do and how we help and benefit designers, particularly in the design of buildings. And then a couple of case studies and experiences from architectural firms, case studies at different stages of the design phases of buildings and how they have used FenestraPro. I'm one of the founders of FenestraPro. I'm an architectural technologist by profession, I suppose, originally from DIT or TU Dublin, as we are now told we have to call it. I did a master's a number of years ago in environmental design, and at the time, myself and my colleague had a small architectural firm based here in Dublin. A lot of it was spent in our own respective specialisms, particularly towards the end of that, that part of our professional life, I suppose. My own in environmental design days and facade engineering, and I suppose it was those two areas that led to the concept of FenestraPro. We very much recognized that there was a requirement for a tool, for software that could allow designers to design facades, particularly, and building envelopes that could, comply with building regulations or codes, achieve the kind of energy building performance that they wanted to achieve without compromising the aesthetic facade, the aesthetic, design of the building. Or in other words, like, how do we design buildings with lots of glass, or that look the way that we want it to look, but will also perform the way that we want them to perform. So whether it be in Dublin or Dubai, as some of the buildings we've been involved with over the years, how do we make them look modern and have a beautiful facade and all of those kind of things, but not overheat or not lose a lot of heat through that glazing, or not below performance daylighting and all of those kind of things. Or in other words, how do we allow designers to design buildings better? How do we understand the implications of those design decisions at an early stage? I know there's a couple of architects here, but I think everyone knows that energy modeling is not a simple process. It's it's difficult. It's a very engineering, very complex kind of process. And FenestraPro is a design tool for architects and designers at an early stage. So before that really deep dive energy modeling, within Revit, within those early design stages of a project, to allow them, as I said, understand the implications of their design decisions on the energy performance of the building. The couple of, things in that space, those few drivers, I suppose, energy performance, climate change, has caused a lot of political upheaval, or political solutions, or whatever that might be, through accords and improved or more stringent regulations, whether it be Part L or ASHRAE or LEED or all of these kind of things. There is a requirement for increased energy performance and better energy efficiency within buildings. Added to that, there's technological advances in glazing and in facade components and elements. Over the last 10 years particularly, there's a lot better glass out there. And by better, I mean we can have a lot better thermal performance for that glazing without completely restricting the amount of daylighting that comes in. Or we can have a very high performing solar control glass that still has a good thermal performance, or whatever those cases may be. So we're starting to see glass that is solving problems across the board, And then added to that, a couple of people have already touched on it this morning, is BIM. So building information modeling has, particularly in the last 10 years, rapidly increased its exposure across building projects, and that has enabled us particularly to jump on that and leverage that. So when we have a building information model, we have a virtual representation of that building, not just a 3D model of it, but also the quantities, the performances of different components or different elements. We can visualize, we can quantify, we can understand very quickly how those things are going to perform. So let's take the first one. First of all, energy efficiency. So if we take a typical office building, We have all sorts of energy uses of that building, but we're going to have a lot of it is driven by the facade, and a lot of it is influenced by the facade. So we have heat loss through that envelope, whether through the floor, the roof, the walls, the glazing, accounts for about 10, 12%. About 20%, 19, 20% is artificial lighting, or you could say the lack of natural day lighting. We're always going to need natural lighting or artificial lighting, obviously, but if we can reduce that requirement, we're going to reduce the requirement for energy use. And, we all love naturally lit spaces, and, we're not one today, but, whether it be studios, classrooms, offices, naturally lit spaces are more, in keeping with, better performing spaces, I suppose. And then a big one, heating and cooling within a space. So, the requirement or the amount of glazing is directly going to influence that. So the amount of heat that's lost through glass or through wall systems or whatever that may be, but also the amount of heat that's gained from the sun, from south-facing glazing. We've all been there sitting in a very hot space that could be November, December, but the sun is shining through. And how do we control that, and how do we understand that and manage that? So all of those kind of things account for 57%-ish, but certainly like half of the building's energy use is very much influenced by the facade. And if we take that in a bit of a wider context and look at global end energy use, and I know this is a big leap, but I'm just to make a point, the built environment accounts for about 39%, 40% of global energy use. If we say commercial buildings, which is where FenestraPro is really based or targeted on, is about half of that, or 19% of global end energy use. If we're saying about half of a building's use is directly influenced by the facade, well, about 10% of our energy use is really driven by a facade, of like a building envelope. And like I said, I know that's muddy science, but again, just to make a quick point around it. And then those technological advances in glazing and in facade components, we have thermal performance, so the amount of heat lost. And we know that glass or glazing loses heat quicker than a wall, right? And that's, there's not much we're going to be able to do that for a long time. But we also know that glass will allow solar gains and heat load within a space, and also allow daylighting within the space. So there's three very conflicting considerations there. The more glass I have, the poorer the thermal performance, but the better my natural daylight. But the more heat gain I'm going to have that I'll have to cool. So how do we find that optimal solution, and how do we understand what's the best, way forward within those three considerations? And that's, I suppose, that sweet spot is where FenestraPro operates. Building information modeling then, as well, as I said, has enabled us to kind of start quantifying this and jumping on board, understanding quantities and performances of the building and the building envelope. And over the past 10 to 15 years, that has really come on stream in a big way, particularly, in the United States. We found that I think, I can't remember the figure, but certainly 90% of architectural firms are using BIM, and of those 80, 90% are using Revit. So it really is the market leader. Maybe Europe is slightly different with, I can't remember, ArchiCAD or different, BIM tools, but Revit is really the one that we have jumped on board and started using as a platform. So FenestraPro, within FenestraPro, we provide facade design tools that allow architects design building facades quicker, more cost effectively, and crucially earlier in the process, and allows the designer maintain aesthetic control over their designs. In other words, when we design something at an early stage, it's not going to start getting changed late on by the cost consultant, the mechanical engineer, the client. And sorry, I know there's a few developers in the room, but that the architect can make sure that the decisions they make on the facade are going to carry through the process. So a few benefits of that. We can very much streamline the design process of the facade. If we know we're going to need shading devices, we know the depth of those shading. We know, are they going to be horizontal or vertical? We know, what type of glass we're going to use, how much of that glass. And it's not going to reiterate, it's not going to be reworked, it's not going to change late on in the process. And as I said, that allows the architect to maintain aesthetic control over the process. And, know that they can defend their designs as the building gets more and more detailed. Code compliance is a big one. Obviously every building, has a lot of regulations that we need to achieve. And again, we can make sure that the envelope and the facade is going to achieve those performances from an early stage. And, FenestraPro, we can create different codes and regulations, and we can see, is the building, digital representation of that building information model, is it compliant or non-compliant? And a big one from where we started in FenestraPro is it's intuitive. I used IES a lot, which is like a deep dive energy modeling tool, and it's like brain damage. You know what I mean? I'm not an engineer, but like it's one of those really detailed things. A tick on or off is going to make huge difference, and I don't know what that tick does. You know what I mean? So what we've tried to do is make it more intuitive, more visual, more design-led for the early stages. A couple of things that FenestraPro does, and I'm sorry, these are a little bit small, but I'll talk through them. How much glass should we or can we use on a building? What's the optimal glass to wall ratio? I was told a story from a large firm here in Dublin that they were doing a really big development that you'll know down the river here, and they had a facade consultant, and at an early point they said, what should our glass to wall ratio be? And the facade consultant said, well, just do 60-40 and come back to us and we'll see how, you know what I mean? And it was just so like muddy, and that's one of the things that I suppose FenestraPro starts looking at. What's that optimal glass to wall ratio? But then also, where should that glazing be? So if we have 60-40, just to take that figure, where is that 40% of glazing? It's certainly not 40% all the way around the building. There's going to be more to certain facades, and what's that optimal figure? But we can also start controlling that, and we can say, well, actually, I want 80% to the south, and because it's a key streetscape or it's a, curtain wall or whatever. So, but what's the implications of that going to be? Am I going to get massive heat gains? Am I going to start needing to provide shading devices, improved glass types, or whatever that might be? We can establish performance values of the envelope based on code compliance, based on regulations, and see very quickly, does my building comply or not comply? What changes will I need to make very quickly? Again, in design stage, we don't need to send it off to a mechanical engineer, wait 2 weeks for them to come back to give us some advice that we have already moved past that, and then we need to go back and reiterate. You get the gist, Shading solutions, very quickly we can start modeling on, dragging a slider to start, seeing the implications of what will happen when my shading is this deep, I'll reduce my heat gains within that space, but I'm also going to significantly reduce my natural daylighting. And again, those implications and what does that mean to the building? We consider shading effects. So a lot of urban areas, for example, will have buildings all the way around the site that is going to offer a huge amount of shading on facades. So, we might say, well, we can't do that much glass because there's going to be massive overheats in the space, but we've a 10-story building across the street that is going to shade our facade 60% of the year. You know what I mean? So it's about very quickly understanding that and modeling that. We can automatically apply glazing solutions. So whether it be curtain walls or glazing window penetrations, we can say, I want a daylight value of X in my space, and FenestraPro will automatically start populating on the appropriate amount of glazing. But we can also say, but I want the window size to be 1 meter by 2 meters, and it will change and appropriately put on the meter by 2 meters, to that area of glass, whether it be a window or curtain walls or whatever that might be, Intuitive search and comparison of glazing specs. So we've been lucky enough in the past couple of years past year really, to enter into partnerships with 2 really big glass companies, Vitro Glass and Guardian Glass in the United States. They've recognized that to get their product spec'd earlier within the design of the building means that spec will stick through the design process, and allowing the architect spec their products based on the performance values. So FenestraPro can say, I want a U value of X and a daylight performance of Y, and FenestraPro will spit out all of the glass types that's going to achieve that, but then also apply it onto the building information model and apply those properties. We have things like facade visualizers to understand the performance and the location. We have a very detailed thermal performance analysis tool that can start understanding frame and distance from the center pane and boundary conditions and all of these kind of really detailed stuff that is getting quite mind-blowing at this time in the morning. But and then architects and designers, look, design is a sales job as much as anything else, and we make decisions. We've got to be able to demonstrate why we've made those decisions, and very often graphically is the way to do that. So we can report and generate analytics and data that can demonstrate why we have made these decisions, and very quickly do these with clients and with design teams, and play around with different solutions and different specs or whatever. And as I said, Revit is where we are at the moment. We're about to launch a Rhino plugin, Rhino support. With Rhino's a much more design-led 3D modeling tool, but used nonetheless quite a lot. But yeah, Revit for us is where it was from quite an early stage. So we've been lucky enough in the last few years to really pull in some of the larger firms, particularly in the United States. That's where we've put a lot of effort in. And firms like Gensler and HKS and SOM are starting to see the benefits of that and are executing it firm-wide and are putting FenestraPro on, all of their designers' machines, or certainly all of the designers that touch the facade at different stages. So just to talk about very briefly, I don't know how I'm doing for time, but very briefly about a couple of case studies. FenestraPro can be used at any stage of the design process, I suppose, and using different benefits at different stages. So Page, really early Page, is a big Texas firm. They were looking at a competition for a higher ed building in Houston, for the University of Houston. And I mean, like very often competitions can be a bit of a exercise in trying to assemble as much information as quickly as possible and demonstrate and graphically show it, and they used FenestraPro very effectively because they had a very simple mass. They had a footprint of the building. They were able to extrude it within Revit and very quickly understand the glass to wall ratio. And what they did was they put 10%, 20%, 30%, right up to 90% glass to wall on the building, and looked at I know this is very small, I'm sorry about that, but they looked at the solar loads for all of that range of glass. And then they were able to strike a range that it was appropriate based on the code, and then they were able to strike a range across the x-axis where shading would be beneficial. So within a couple of hours, they had some really sort of strong, robust energy performance back up to some of their design decisions, and they actually won that project and designing at the moment. Schematic design, so a little bit later in the process, but early nonetheless. Very large firm who are very sensitive about their brand, and I know because I've had my wrist slapped before. We're designing a Four Seasons hotel in Lagos, Nigeria. Lagos is more or less on the equator, so very kind of harsh solar patterns in that all of your orientations will require shading. It's not that more traditional south-facing that we would have. So they had a form of the building, and they looked at two options. First of all, they again just automatically distributed their glazing around the building, and they had slightly more to the south, a little bit less to the north, somewhere in between east and west, and they were able to start understanding then from that where to place their core and their circulation within the building. They started understanding the difference of rooms and how that glazing was going to affect their bedrooms internally. But then they did another option that they fixed 40% glazing across all of their orientations, and they used their balconies within FenestraPro as shading devices to shade those spaces. So in other words, they had deeper balconies to one orientation, slightly less deep, which led them to have more premier rooms or different types of spaces. And it was just an interesting case study in that they very much allowed the facade to drive some of the internal spaces and the energy performance of that to make some of their decisions around that. AECOM in New York were doing a school. The New York Schools Authority, I can't remember, Schools Construction Authority or something, have some pretty strict parameters within which to work, which FenestraPro just was in a real sweet spot for, because they had a couple of things like a maximum glass to wall ratio, so that you could only have 25% glass to wall, but they also had different fabric specifications, performance requirements. So the guys there in New York were able to lock 25% within FenestraPro. In other words, their glass would never go beyond that 25%, and they could play around with it just very sort of easily, with knowing that it was always going to stay within that. But then as the spaces and as the design started coming together, a lot of that glazing was to the south. So then again, were able to start looking at shading solutions and different ways of managing those overheats, and what would that do to daylighting. I don't know if anyone's been involved in schools, but daylighting is a huge thing within classrooms, and what would their shading devices do to the daylighting. So again, just very quickly, a really sort of good case study in terms of how quickly and easily they were able to execute it. And then a very detailed building that Skidmore, Owens and Merrill did for the Department of Transport in Boston, I think. Boston, yeah. This was construction documentation, or tender really, and they had these really heavy, detailed Revit models with these custom panels. So the panels came as modular systems with, and this extruded fin, and they had a glass element, and they had a solid panel, and then obviously they had framing. They also had a facade consultant who had burned their fees and wouldn't do any more on it, but had told them that the panel overall had to have a thermal performance of X. But if we know that glass and solid panel and concrete and frame all have different thermal performances, how do we know what that X is for, when we start changing different ratios between them? Or what happens when I change my frame from 2 inches wide to 2.5 inches wide? So again, FenestraPro gave them a really quick and easy way of defending that, 0.25 U value or whatever it was, staying within the typology, using their really detailed model and executing it quite well. So in summary, I have no notes, and I'm not too sure what my summary is, but I suppose, I've concentrated a lot on the design stages of the building, but FenestraPro, I suppose, allows you to streamline your design process, very much manage the, capital costs of the building, but also optimize your operational costs and, understand all of these implications very early on in the process. So thanks very much, and happy to take any questions afterwards. Cheers.